Hello and welcome. Today we are going to explore Cartesian products, isomorphisms, and the arithmetic rules of combination. Before we dive deep into the math, let's learn the secret code. What do the symbols mean? First, we have our capital letters like X, Y, and Z. I want you to think of these as bags filled with items. The individual items hiding inside these bags are written as lowercase letters like X, Y, and Z. Next is the times sign. In this context, it simply means make a pair. So when you see X times Y, it means you are taking one item from bag X and one item from bag Y to make a combination, written as XY. Then we have the wavy equals sign. This tells us that two things are basically the same thing. The items inside might be packaged slightly differently, but there is a perfect one-to-one match between them. Finally, we have the number 1. Now, this isn't the regular number 1 that you use for counting. Instead, it represents a special bag that contains exactly one boring standard item, which we can just call a star. Now that we know the code, let's look at the formal definition. How do we formally write down this idea of making a pair? This brings us to a concept called the Cartesian product. The formula looks like this. X times Y equals all possible pairs XY such that X comes from bag X and Y comes from bag Y. Here's how you would read this formula out loud. The combination of bag X and bag Y is the set of all possible pairs XY such that X comes from bag X and Y comes from bag Y. Let's use a real-world example to make it clear. If bag X has red and blue shirts and bag Y has jeans and khakis pants, then X times Y is simply the set of all 4 possible outfits you can create by mixing and matching them. You might be wondering, what about 3 bags? We already know that X times Y makes a pair, XY. But what happens if we add a 3rd bag, creating X times Y times Z? This is called the triple combo. When you see X times Y times Z without any parentheses grouping the letters together, it means you are making a strict 3-part combo all at once. We call this an ordered triple. The set is beautifully written like this. The set of all possible triples X, Y, Z such that X comes from bag X, Y comes from bag Y, and Z comes from bag Z. To help picture this, imagine a lunch tray with 3 built-in slots. You put a burger, X, in slot 1, some fries, Y, in slot 2, and a drink, Z, in slot 3. There are no extra boxes hidden inside other boxes. It's just 3 items sitting perfectly in a row. Let's take a moment to discuss a very crucial concept, equal versus isomorphic. Why do we sometimes use that wavy equal sign instead of a strict equal sign? Well, equal means 2 things are exactly identical. Isomorphic, on the other hand, means they contain the same information, different packaging. Let's look at the packaging analogy. Think of those curved parentheses as little cardboard boxes. For instance, parentheses X, parentheses Y, Z is a box that contains an item X alongside a smaller box holding YZ. Conversely, parentheses X, Y, close parentheses, Z is a box containing a smaller box holding XY along with an item Z on the side. These are physically different boxes, so they are not strictly equal. However, if you look inside, they hold the exact same 3 items in the exact same order. Because of this lovely symmetry, we say they are isomorphic. Now we're ready to dive into the arithmetic rules. Rule 1 is grouping doesn't matter. The math looks like this. X times parentheses Y times Z is isomorphic to parentheses X times Y times Z, which is isomorphic to X times Y times Z. What this means is called associativity. If you're putting together a 3-part combo meal, let's say burger X, fries Y, and drink Z,
It really doesn't matter how you group them in your takeout bags. At the end of the day, the meal contains the exact same food. When matching the elements to show this isomorphism, we see that x, parentheses yz corresponds perfectly to parentheses xy, z, which directly corresponds to our open tray xyz. Moving on to Rule 2, the do-nothing combo. The math here is x times 1 is isomorphic to 1 times x, which is isomorphic to x. This represents the concept of identity. Remember that our 1 is just a bag with a single generic item, like a star. If you pair your meaningful choices from bag X with a bag that offers absolutely no real choices, you simply end up with your original choices from X. Matching the elements, we see that x, star corresponds gracefully to star, x, which effectively is just the item x. On the left side, you have a box with x and a useless star. On the right, you just have the item x. The actual useful information you hold is completely identical. Next is a very intuitive one. Rule 3, order doesn't matter. The math is simply x times y is isomorphic to y times x. This is known as commutativity. It means that pairing a shirt from bag X and pants from bag Y gives you the exact same final outfit as if you picked the pants first and the shirt second. When matching the elements, we see x, y corresponds to y, x. Now, strictly speaking, they are not exactly equal because the order sitting inside the box is reversed. But our wavy isomorphism symbol tells us there's a perfect, natural rule to translate between them. You just effortlessly swap the items. Now for a slightly different concept. Rule 4, the empty bag, or 0. The math states that x times the empty set equals the empty set. This can also be written as x times empty equals empty. Notice that here we're back to using the strict equal sign. Why is that? Well, the symbol representing the empty set represents a completely empty bag. It has 0 items inside. Here's the logic. To make a pair, xy, the rule strictly says you must pick one item from x and one item from the second bag. But if the second bag is empty, you can never complete the pair. How many successful pairs can you actually make? Exactly 0. Think of this simple analogy. If a restaurant offers a burger and drink combo, but they're completely out of drinks, you simply cannot buy that combo. The number of combos available to you drops all the way down to 0. Let's bring it all together in our summary. These wonderful rules show us that combining sets behave exactly like multiplying regular numbers. For associativity, grouping sets works just like 2 times 3 times 4 is equal to 2 times parentheses 3 times 4. For commutativity, swapping the order works smoothly, like 6 times 7 is equal to 7 times 6. For identity, represented by the number 1, it behaves just like 5 times 1 is equal to 5. And for 0, representing an empty bag, it behaves perfectly like 8 times 0 is equal to 0. As you can see, math is beautifully consistent. Thank you for taking the time to join me on this beginner's guide.